Om Swastiastu. Hello, good morning, everyone. How are you today? So, I hope you are all doing well. Now, before we begin, let me introduce myself. My name is Nilo Heka Putri Ani, and you can call me Eka. Now, so today, we are going to learn about geometric transformation. Okay, let's get started. Geometric transformation. In mathematics, a transformation is a process that moves or changes a geometric figure, and we can call the pre-image to create a new figure, or we can call the image. Now, there are four main types of transformation. There are translation, reflection, rotation, and dilatation. Okay. Okay, now the first three, translation, reflection, and rotation are called rigid transformation or isometries because they change only the position of the figure, keeping its size and shape exactly the same. But dilation is a non-rigid transformation because it changes the size of the figure. Okay, next. Okay, first we are going to learn about translation. Okay, a translation is a transformation that moves every point of a figure the same distance in the same direction. Okay, you can think of a translation simply as a slide or a sieve. Because a translation only changes the position of a figure, leaving its shape, size, and orientation completely unchanged, it is classified as a rigid transformation or an isometry. Okay. Transformation rule. To find the new coordinates of a point after a translation, simply add the horizontal shift A to the original x coordinate and the vertical shift B to the original y coordinate. You can use this rule. Okay. Point P, x, comma, y is translated by T, A, comma, B to P primes x plus A, comma, y plus B. So we can also use this formula. X prime is equal to x plus A and y prime is equal to y plus B. Or in metric form, you can use this. The column of x prime and y prime is equal to column of x and y plus column of a and b. For example, gonna translate point a comma a 3,4 by t 2 comma minus 1. So we can use this formula and we got x prime is equal to 3 plus 2 and we got 5. Then y prime is equal to 4 plus minus 1 and we get 3. So the image is a prime of 5 comma 3. Okay, do you understand? Next. Okay, the second topic is uh, reflection. Okay. What is reflection? Okay. Reflection is a transformation that flips a figure over a line called the line of reflection or mirror line. Okay. The resulting image is a mirror reflection of the original pre-image. Because a reflection only changes the orientation of the figure but keeps its shape and size exactly the same, it is classified as a rigid transformation or isometry. Okay, this is the image of a reflection. Mhm. Okay, same as translation, the reflection also have a coordinate rule. Okay, here are the standard reflection formulas across different axes or lines. Okay, you can read this. x-axis, the pre-image x comma y, and we get the image x comma minus y, and so on. Then, okay, for example, okay, reflect point B minus 2 comma 5 across the y-axis. Okay. Now, following the rule x comma y to minus x comma y, the sign of the x coordinate changes. Okay, so we get the image is b prime is b prime 2 comma 5. Okay, from minus 2 to be 2. So we get the image is b prime 2 comma 5. 2 comma 5. Okay, next. So the next topic is rotation. Okay, rotation is a transformation that turns a figure around a fixed point called the center of rotation. Now, the amount of turning is called the rotation angle, or we can call theta, because a rotation only changes the position and orientation of a figure, leaving its shape and size exactly the same. It is classified as a rigid transformation or an isometry. You can see this picture. Okay, now. Okay, you must note that about center of rotation, the fixed point that everything spins around. Okay, this point doesn't move during the transformation. Okay. Okay. Rotation rules. Okay, centered at the origin O 0, 0 with angle theta, and we have the rule x prime is equal to x times cos theta minus y times sin theta, and y prime is equal to x times sin theta plus y times cos theta, or in metric form, we can use this. Next, centered at the origin M A comma B with angle theta. Okay, and we have the formula x prime is equal to x minus A times cos theta minus y minus B times sin theta plus A. And y prime is equal to x minus A times sin theta plus y minus B times cos theta plus B. Or in matrix form, you can write this. Okay. Next, we are going to move on to an example. Okay. Rotated point P5, 2 by 90 degrees counterclockwise around the center M 1, 3. Okay. Solution here, x is equal to 5, y is equal to 2, a is equal to 1, and b is equal to 3. So we got this. X prime is equal to 5 minus 1 times cos 90 degrees minus 2 minus 3 times sin 90 degrees plus 1, and we get 2. Okay. So y prime is equal to 5 minus 1 times sin 90 degree plus 2 minus 3 times cos 90 degree plus 3, and we get 7. So the image is P prime is P prime 2, 7. Okay, next. Okay, the last topic in transformation is dilatation. What is dilatation? Okay, a dilatation is a transformation that produces an image that is the same shape as the original figure pre-image, but a different size. It stretches or shrink the original figure. Now, unlike rigid transformation, translation, reflection, rotation. Dilatation is a non-isometric transformation because it alters the length of side while keeping the angles congruent. Okay. Okay. Now, to perform a dilatation, you need two essential pieces of information. Okay. Center of dilatation, a fixed point from which the figure is enlarged or reduced. Okay. Two, scale factor, or we can call K. Nah, the ratio of the side length of the image to the corresponding side length of the pre-image. Now, the value, okay, wait. Okay, then the value of the scale factor K determines how the figure changes. First, enlargement. If K, if the magnitude of K, uh, uh, mm, uh, sorry. Okay, first, enlargement. If the absolute value of K is more than 1, the image gets bigger than the pre-image. Two, reduction. Okay, if the absolute value of K is more than 0 but less than 1, the image gets smaller than the pre-image. And last, no change. Okay, if K is equal to 1, the image remains identical to the pre-image. And negative scale factor, okay, if K is negative, the figure is dilated and interfered, okay, rotated 180 degrees across the center of dilatation. Okay, next. Dilatation rules. Okay. First, we will learn about dilatation centered at the origin O 0, 0. Okay, when the dilatation is centered at the origin, you simply multiply both the x and y coordinate of the pre-image by the scale factor k. Okay, is point P with coordinate x, y. Okay, dilated with 0, key to P prime with coordinate k times x, k times y, or in metric form, this. The second, dilatation centered at an arbitrary point M A, B. When the center of dilatation is a specific point A, B, instead of 0, 0, we must subtract the center coordinate before multiplying by k and add them back at the end. Okay, this is the formula. The point P with coordinate x, y dilated by n A, B with scalar k to be a P prime with coordinate k times x minus a plus minus a plus a, k times y minus b plus b, or in metric forms you can use this. Okay. For example, delete point A with coordinates 3, minus 2 centered at the origin with a scale factor of k is equal to 4. Okay, the solution, x prime is equal to 4 times 3 and we get 12, and y prime is equal to 4 times minus 2 and we get 4 times negative 2 and we get negative age. So the image is A prime with coordinate 12, negative 8. Okay, now about transformation. Uh, I have some problem for you. So I hope you can try to solve this problem in your home. Okay, I have two problems about transformation, geometric transformation. Okay, so you can try to solve this problem. Do your best. Okay, that's all about my presentation about geometric transformation. Okay, thank you for watching and bye bye. Om Santi 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 Om.